Dear students, today we'll be learning about signal with the help of its definition and some examples. Signal is generally the first topic which is taught in subjects like signals and system in electronics engineering and some other branches also like electrical engineering and biomedical engineering. And it is also taught in subjects like digital signal processing and biomedical signal processing. So, today we'll be trying to understand this term with the help of some examples. Before proceeding further, I would like to request you to kindly subscribe this channel so that whenever I upload a new video, you can get information about it. Basically, signal is not a new term for all of us. We come across signals on day-to-day basis. For example, currently I am speaking, so I am generating a voice signal or a speech signal. Whenever you speak, you generate a voice or speech signal. Lot of signals are generated from our body also. For example, muscle signal, brain signal, signals from cardiovascular system. So lot of signals are generated. However, a very simple example of a signal is yt is equal to sine of t. A very simple example of signal is yt is equal to sine of t. If I plot this, so for different values of t, I will have to plot yt. So if I take t equal to 0, so sine 0 will be 0. So I'll get 1 point here. If I take t equal to 90, sine 90 will be 1. So I'll get 1 point here. Again, sine 180 will be 0 and so on. So we all know that sine wave looks like this. So in this simple example of signal yt equal to sine t, you can see that there are two variables, y and t. The second variable is t. So it means that this particular signal has two variables, and variables means the something which is not fixed, which changes. So obviously the value of t changes and accordingly the value of y changes. So we can say that y is dependent on t and therefore y is called dependent variable and t is called independent variable. So we can see that signal is nothing but a function. Yt is a function of t. So signal is nothing but it is a function which is dependent on one or more independent variables. One or more independent variables. For example, in this case, the function yt is dependent on t. T is the independent variable. There can be certain situations where a function can be dependent on more than one independent variables. For example, if I write y t1 comma t2 is equal to cos of t1 plus sine of t2. So here the function is dependent on more than one independent variables. I hope the definition of signal is clear to you. Signal is nothing but it is a function which is dependent on one or more independent variables. Now let us take some more examples of signal. This was the first example. There can be many examples. For example, if I write yt is equal to t, this is also a type of signal which is called as ramp signal. So if I plot this signal t with respect to yt, which is also equal to t, if I take t0, I'll get yt also equal to 0 because ultimately yt is equal to t. If I take t1, I'll get yt also equal to 1. If I take t2, I'll get yt also equal to 2 because yt is equal to t. And if I join all the points, I'll get a straight line like this. This is called ramp signal. Similarly, there are other signals. For example, if I want to plot yt is equal to t square. So again, for different values of t, I can plot yt. Means you should be very clear that t is the independent variable, because on the basis of values of t, we are getting the values of yt. If t equal to 0, I'll get t square equal to 0. If t equal to 1, I'll get yt that is equal to t square also equal to 1. But if t equal to 2, I'll get t square equal to 4. So I'll get some point here. If this is 1, 2, 3, 4. So here I'll get the graph something like this. This is also a type of signal. Then we have another signal called exponential signal, e to the power minus at. Again, if you plot it, this is y of t and this is t. So for t equal to 0, e to the power 0 will be 1. Sorry, for t equal to 0, e to the power 0 will be equal to 1. So suppose this is 1, and when you increase the value of t, for example, if you take t equal to 2 or t equal to 3, you can use calculators and you can solve it. You will find that its value gets decreased. Means the highest value is at t equal to 0, and when you put t equal to 1 or 2 or 3, the value gets decreased. So graph is like this. So this is called exponential signal. So I hope you all got the concept of signals and how signals are plotted and some of its examples. In the next lecture or in the next video, I'll be talking about different types of signal. Thank you very much.